welcome to Biota Live. I'm Tom Barbalet, and this is being recorded live on TalkShoe, January 23rd, 2010. Well, we normally start with news and notes, but we have Gerald de Jong on the line, and I understand it's midnight where you're calling from currently, Gerald. Once again, I mean, from 5 a.m. to midnight, you're going above and beyond the call of duty in order to appear on Biota Live. Happy New Year.
No, thank you very much. It's just midnight. That's not too bad.
Okay.
Better than 5 o'clock in the morning.
For folks listening in, I'm going to try and avoid covering most of the information that you've already put in your Darwin at Home podcasts, because I think they're really the primary place that people should be going to get Darwin at Home information. But there's some interesting twists and turns associated with what's going with Darwin at Home currently. Can you just kind of give a summary of the game idea, the pounce idea, and some of the elements of reincarnation that seems to be coming through Darwin at Home currently?
Yeah, well, you call it reincarnation. I would sort of classify it otherwise. But anyway, so the idea is that in Darwin at Home, I'm trying to put together a game that people will be interested in playing and will come back to. I need a system so that one can capture the other, so that they can actually compete with each other. And there has to be some way to resolve a conflict if somebody is attacking someone. And so I came up with the idea of a pounce, because it's very easy to do in the stuff I've already got. So I can just have a gene for pouncing, and then whoever's at the highest altitude at the moment of contact is the winner of the conflict. So it becomes sort of like checkers, where one piece goes on top of another piece.
But these are actual players, aren't they? They're not. It's not just checker pieces where it's almost like a god game where the person is looking down, moving these entities. These entities actually represent players within the game, don't they? Yeah,
each player is represented by one of these creatures, and I've got a name for them now. I'm calling them tetragotchis, because several times while demonstrating to people and showing people the project as it was developing, several times people came up with the idea that they were saying it reminds me of having a Tamagotchi, because life continues on for your Darwin at Home creature after you log out, and very slow motion, but it continues on. So people have the sense that there's something still out there that they're responsible for and that belongs to them, and that's kind of the idea of a Tamagotchi. So I picked the name Tetragotchi and discovered immediately that it was completely unique, because the Google search returned nothing whatsoever. And that's a very rare event. So I figured that's the name I'm going to choose. It's going to be called Tetragotchis.
Do you know the legacy of artificial life development in the Tamagotchis?
Not at all. I've never even had one in my hands.
Oh, well, this is an interesting story, and as it involves yours truly, I can tell some of it. I'll try to give you a summarized version. But I was supposed to speak at the Biota 3 conference that you attended. I couldn't make it because I was traveling around the world. But Sue Wilcox, who organized Biota 3, contacted me and kind of continued the discussion. And she had a friend in Hawaii called Ian Kitajima, who I'm not sure whether he had some connection with Bandai, who made the Tamagotchi. I'm not sure whether Bandai was going to invest in his R&D company or whatever the history was. But basically, he had spent maybe 12 months working with an engineer, and they developed a brick-like device which ran some bizarre version of BASIC. And that's all they'd done within the year. And Sue Wilcox said, you've got to talk to Tom Barbalet, because he's got some background associated with artificial life simulation, and he might be able to solve this for you. So I worked with Ian Kitajima for about 6 months, and we created what we called the iToy, which was basically the next generation of Tamagotchi, except it had infrared and basically long-term play. And I started it with a command line simulation. So my interest was to take the existing Tamagotchi technology and move it into something that was far more like an artificial life creature, but also that could mate and mutate and battle. And because these things, rather than the previous Tamagotchis, I think they had like metal nipples that had to be contacted in order to actually communicate information. These things were more like you'd have maybe 6 or 10 kids in the playground that would each kind of form tribes, and they'd just literally hold the things, and the infrared communication would create battles and these kind of interactions. So the prototype that I developed was also licensable, and at the time, our mutual friend Douglas Rushkoff was working with Marvel and various other IP companies, fundamentally IP companies, who were looking to take this kind of technology and map their own intellectual property onto it. So with this, it was really the idea that the Tamagotchi was almost like the Microsoft operating system, that it could run on any hardware, or even the Linux operating system. Let's be a little bit more open source. And so I demonstrated all this stuff, and they were all very interested. And then the intellectual property rights holders started to realize that if Marvel and Disney both bought into this, then you could have some kind of hybridized Captain America, Donald Duck thing with, combined intellectual property, and it got very interesting. But then, unfortunately, what I like to call the speculative technology industry, which wasn't really connected to the dot-coms, except everyone thought it was part of the dot-coms, kind of collapsed. But I did walk away with the underlying intellectual property associated with the iToy, which had a kind of compiler interface to get the information into it, but then basically it was in the wild after that. And my background doing long period simulation, like taking simulations and running them for weeks, basically text-based simulations, to see how these things would evolve and what kind of problems would happen in 10 years' time if the play characteristics continued, fed back into that. So Ian and I parted our ways. I maintained the intellectual property, but somehow Bandai took probably early papers that we'd done, none of the underlying stuff, and then moved it into the next generation of Tamagotchi. So it's still, the next generation still wasn't as rich as the stuff that I'd developed. And I'm always disappointed, particularly because I saw the real market of these things into plush toys, into almost kind of robotic plush toys, because I guess the Furbies and other probably first generations of these things were coming together at the same time. But I thought all these really interesting artificial life principles mapped very well back into the Tamagotchi toys, particularly, as you say, this whole notion that it exists independently if you put it in a drawer. Now, the early ones were almost puerile. I mean, basically, they just produced waste products and things like that. That was like the first and second generation Tamagotchis. So really, all you were doing was cleaning up after the pet. But the stuff that I was more interested was more about kind of fantasy universes and the fact that these things were, whilst you saw the creature, you also saw a window into the fantasy universe as well. And I think that legacy is really what you're picking up on with regards to this idea of the Tetragotchi too.
Yeah, it's funny actually how you can play with time, and since the issue here is evolution, and evolution is something that you can really only start to understand when you really stretch your mind to try to fathom, just huge stretches of time. So in the Darwin-at-Home game, I have to play with time. And the way I'm doing it now is that it's a very calm, slow, relaxed game. Actually, everything happens very slowly, so you can pretty well relax. You know that things are the things you see happening, however action-packed they are, because if you run them fast, which you do on the client, you see that it's all it's all about movement and running and jumping, and so it's an action game, but it's so slow that it's going to be something like a strategy game. And I was thinking it actually adds one strange element for a computer game. It adds suspense.
But you're also using similar dynamics, I guess, to things like Farmville currently, in terms of allowing people to have everyday lives and just periodically peering into their Darwin-at-Home, Tetragotchi universe. I mean, that's part of the time thing as well, isn't it?
I think it will be sort of, by its nature, a little more involving than that, because you kind of have to keep paying some attention to your Tetragotchi. So that's going to be, it's a little less of a casual game. Maybe there's a variation that I could make of it that was more like that. And maybe that's something I'll be able to do in the future when I learn more about how this works as a game in the first place.
Now, with regards to what I'm calling reincarnation, you were kind of describing this with regards to pounce, but the illustration that you gave in the DarwinAtHome podcast was that a new player would probably be pounced almost instantly when they entered the environment, but in the process of being pounced, they would actually return with some of the characteristics, if not all of the characteristics of the creature that had pounced it, and the creature that pounced it would then get a hybridizing of the best characteristics from both the pouncee and the pouncer, so to speak. Is that the logic that you're playing with?
Except for that last thing, there's no hybridization whatsoever. It's purely it's kind of like the pounce to capture another is on the one hand it's eating, but it's on the other hand it's also creating progeny, because the pounced upon individual, who's actually the tetragotchi of somebody out there in the world, will become a child of the pouncer. So which is a mutation with it's basically a mutated clone. So there's no hybridization going on. So eventually, and what it actually copies is the structure genes. So you build a sort of similarly structured body, but it doesn't inherit the movement gene. So that has to be evolved again. And that's and the challenge was actually that I wanted to start with random genes. Like you can't really give it a head start. You give it as little a head start as possible. So I gave it just a head start that everyone starts with random genes, but the people who happen to get a tetragotchi who is capable of moving and can be evolved to move, it will be able to capture others by pouncing on them, and therefore it will spread its capable genes around. So it allows me, on the one hand, to say, okay, everybody's got to start with random genes, and there's a good chance that you're not going to be a very, capable walker. So you better hope that you get pounced, and then you get a second life, which I thought was a pretty good pun.
But it's interesting as well, because the potential is this is going to be in the sphere environment as well, isn't it?
Yeah, everything takes place on the surface of a sphere, and until now I haven't been successful. I haven't spent much time on it actually tweaking the water physics enough to make swimmers sort of feasible. But on land, like you've got islands and you've got sort of peninsulas and all.
So what will happen with the islands is that very quickly you'll almost have like I don't want to use the race metaphor, but almost like dominant races of these tetragotchis, because basically through the pouncing and the occasional mutation, but basically the perpetuating of particular genetic characteristics, super pouncers basically, you'll have islands where these genetic characteristics could be quite different, but each of them would be equivalent super pouncers. What would be interesting, and I think Dave Kerr did this with AI Planet, is the idea of having like floating logs or things like that. So one tetragotchi would, having created a perfect pounce on one particular island, could get on one of these floating logs, or maybe even some bizarre artificial life barge or something like that, and go over to another island where the pounce had been moved in a different direction and see what came out of all of that. I think there's that kind of potential in narrative too, isn't there, Gerald?
Yeah, but I'd like to go keep it one step simpler by what I'm going to do is that as soon as a tetragotchi sort of leaves the land, goes off the coastline into the water, what I'm going to do is switch their gene set. So from that point on, they no longer have land behavior, but they have water behavior. So they could presumably figure some way to flail their limbs and get them, swimming to some degree. They don't have to be terribly good, because if they can get to the other side, they can probably make a lot of kills. So you just have to, do your best to paddle over to the other side. And I hope that's possible. And that would be interesting too, because then even if you became a wonderful pouncer, you'd still have to learn to swim in order to take over the whole world. And I'm not sure, actually, when I start running this, I'm not sure how long a particular game carries on. I think it might be something that's interesting to sort of do in cycles. So, you start a game, and then at a certain point, things sort of, maybe it comes to some sort of a stasis, where it's just sort of everybody's got the same shape, and it's boring. I'm not sure. And in that case, I would probably stop and try and rebuild something and create a new version for the next run.
Certainly. And just thinking of the pouncing move, in the real world, although there could be a wide variety of bizarre pounces that exist in this new universe, but if you think of the way dolphins swim, that could be a pounce on the land in terms of its the body movement, particularly. So maybe pouncing and swimming optimization might be similar things. In terms of, when you think of simulations like Framsticks, for example, and potentially a wide variety of other simulations that don't come to mind, there are other elements which are effective in the kill. In Framsticks, they have, various lasers and poisoning-like things, and, I can imagine a simulation with toxic gas, or actually all the stuff that Eric Burton is posting currently with the notion that you inject your soon-to-be pounced prey with some kind of active substance which may change various aspects of the muscle movement or all these kind of things. I know you're thinking simple currently, but is the plan to move in that kind of direction as well?
I don't know. I like to avoid the things that I would sort of tend to call contrived to start off with. To make too much of a story out of it. I'd like it to be a simple with respect to the story, because a lot of it is the process of evolution, because you can actually see that, and there's also a social aspect to it, because I'm going to set it up so that each Tetragotchi has a sort of a speech balloon above it. And that can be changed at any time. So whenever you encounter a Tetragotchi, you can see the most recently typed message of that Tetragotchi. And by the way, I'm going to see if I can record absolutely everything that happens in the entire universe. What I'm going to be able to do, I built at one point a class called FabBlob, which is capable of packing up a fabric into a binary series of, it serializes it. And I actually at one point built two different ways to use that. One of it was sort of the standard way that holds full detail, and there was a lossy way that was able to store all the numbers, but then in much less detail, and therefore much less space. So what I'm thinking of doing is on the server, storing the entire universe very frequently, and just letting the hard disk fill up with all these sort of frames of activity where all the coordinates of everybody in the entire universe is recorded every, several cycles. As a result, I could later on discover that something interesting happened, back up to it, bring effectively a movie camera to it, and film it from several different angles in retrospect afterwards. That would be interesting. Certainly.
And I think the element of looking into these kind of simulations and being a player in these kind of simulations is something that certainly a number of games have already experimented with, and I think it would be fascinating just to develop a site that was almost like, peering into the fish tank or the world, or doing roving camera views, just for folks who may be interested in entering the environment but wanted to have a look first at the kind of experience that they were going to see. And you've mentioned at previous appearances on Biota Live the idea of also taking this information and creating YouTube movies out of it, and I'm assuming that the technology is there to do that as well.
Yeah, well, that's exactly what I'm talking about when I think about in retrospect, after somebody, for example, mentions that they saw a really interesting kill happen at a certain time in a certain place, that maybe it was possible to sort of cruise over to that place and time, since it's all recorded, and basically set up a YouTube camera. I mean, effectively, you can use something like ray tracing to, from a particular point of view, paint the world. And it can take a while to render that, but once you've got it rendered, it's just a sequence of images, and that's what I've used before to make the movies that I've already got on YouTube.
Certainly.
Or on Google Video, actually.
So in terms of infrastructure, we'll have Peter Newman on the call shortly, but in terms of infrastructure with regards to this kind of game, you've mentioned that you have a lot of the pieces already. In terms of actually putting it up, you're going to do beta testing within the next couple of months. I get that sense. Is that the kind of time frame you've been talking about?
Yeah, I'm actually almost thinking in weeks now, but I'm not exactly sure. I would like to get together with a group of similar nerds in my office and get around the table with everyone with a laptop, and then just have a nice critical brainstorm evening where everybody plays the game available for the first time. So they will probably be more understanding when they encounter things that are not quite right. So, with a session or two like that beforehand, that's when I'll be ready to do something like releasing it online.
Terrific.
And that could be within a few months. I'm sure.
Okay, let's say that. That seems fair. But I like the idea of initially starting with still relatively large time cycles in the real world, but relatively small time cycles in the simulation. So what you're saying currently is, if a pounce takes 3 hours, then obviously people are going to be sitting around laptops for probably 3 to 4 hours to observe that kind of interaction, or at least see the stability. But then you would open it up for maybe a week for a small group of beta testers, maybe a few of these weekly cycles, and then move it more to a month, and then potentially put it out. Is that your thinking with regards to the kind of testing timeframes too?
Yeah, I'm not sure it's going to go in those steps. I'm not taking it all that formally, but I'd certainly like to have a test with a bunch of understanding programmers who might have some good suggestions as well. And only after it survived that test, would I decide to put it online. I plan to use something like Gmail used, where you can once you're in, you can invite others. So that's sort of the plan for getting it out there.
And in terms of using existing social networks, obviously YouTube Out is good for that. And in fact, it's very easy if you've got YouTube Out to link that into Facebook and Twitter and a wide variety of these other social networks. So if you have the group invitation, the kind of show and invite nature of these kind of applications could potentially grow your user base very quickly. But to this end, in terms of the actual infrastructure, what are you thinking about initially, and do you see that eventually it will need to be, farmed out to multiple servers? And is the back end ready to be distributed in that fashion, or is that something that you're not even considering currently?
I don't know. It's something that I have to consider to a certain degree because I really want to launch this thing. And what I have is I have a server on a rack somewhere, which I pay for a monthly fee for. And that's where I have my websites hosted. And that's my machine, so I can put on it what I want. And that's where the server is going to exist. And I've had scalability sort of in mind from the very beginning of this project, because I have to imagine, at least several thousand people playing more or less at the same time. In a way, I approach that by keeping everything really, really small and abstract and simple. So, if I can, what I'm going to be able to do, for example, on the server is keep the entire universe in RAM, so without any concern whatsoever, because all these creatures are not all that big. So that's one thing, you've got it all in RAM, and it's being persisted every once in a while in snapshots. But the client-server interaction is sort of limited enough, because the only thing that comes back from the client to the server is changes in their text balloons above their heads and new genes, which are also very small, network-wise. They're just they're small chunks. So in effect, there's sort of a trickle of information coming back from the client to the server, and so that might make it sort of inherently scalable, I hope, to some degree at least.
This is in part, I guess, why it takes so long to do a pounce, because those kind of interactions, rather than being in the kind of second or even fraction of a second as you would get, for example, in a first-person shooter, is in fact a long-term negotiation that takes about 3 hours in simulated time, but moreover would only be communicated if the if the participant, if the Tetragotchi individual was actually in the environment. If they weren't in the environment, their existence would be purely simulated over this time, and it would only be at the times that they logged in that this information would be communicated. So I do see through your explanation how that would occur.
In this case, I'm not sure if I understood you exactly, but for example, your Tetragotchis remain in this universe. They remain visible, and they remain with the text above it that the person typed the last time they were online.
Certainly.
Yeah.
But in terms of the actual communication part of that, particularly if you have 1,000 Tetragotchi users all logged on at the same time, the network traffic just in communicating the deltas may start to build, but if you expect over a given day that everyone will log in, but not everyone will be logged in at the same time, then obviously the interactions become a lot smaller.
And because the game is sort of slow, that kind of stuff is possible. I mean, in a way, it's going to feel like a strategy game. It's a slow motion action game, but in effect, the fact that you have to periodically log in to make sure things are going well and there's something going on when you're not logged in, it becomes kind of a strategy game.
Do you think, as Farmville does currently, it benefits a group of people that are perpetually logged in?
I don't really know Farmville at all, but in a way, of course, someone who spends a lot of time logged into DarwinAtHome or to the Tetragotchi universe will, of course, be able to evolve a lot further. But that's kind of the things I want to encourage. So, and that would be advantageous.
Certainly. I mean, the addition of these kind of social network games is the fact that the more people you invite, you get benefit for actually doing those invitations. Do you think there's a component that you could map back into the Tetragotchi game? I guess if you invite people in, then they could become part of your clan that wouldn't pounce you. So, I mean, that may be implicitly what you get by inviting people into the Tetragotchi universe. But have you thought about any other weighting that would come through the invitation?
I'm not sure I want to take the approach of weighting like that. There's one interesting aspect here. Inherent in this game is basically, the genealogy amounts to relationships among people who own those Tetragotchis. So, you are the child of effectively another player, or you are the ancestor of a number of other players. There is that genealogy, and that's being maintained, of course. And it's interesting because that sort of creates a almost arbitrary social network that's constantly changing. So, you'd sort of end up in contact potentially with people that you didn't know, but who are also playing and perhaps somewhere else in the world or whatever. So that might be interesting as well. Instead of your regular social network where everybody is known. Certainly.
Well, I found this even doing little things like the Biota podcast, that you develop a social network of people that you've never actually met. And I mean, to this end, your wife and daughter are going to be here in Vegas in July. I mean, I announced previously that there was actually going to be the potential for a Biota conference in 2011, and I think it will be happening in Salt Lake City following the Philosophy of Biology folks conference, maybe at the tail end of that. But it would be wonderful to have you in this part of the world, and I'm assuming as soon as we announce Biota 5, you'll start saving your euros for a flight out for it.
Oh, I certainly hope so, as soon as I hear about it.
Terrific. Yeah, I'd like to formalize it within the next couple of months or so. In terms of Artificial Life 12, that's probably the next big Artificial Life conference that's occurring in your part of the world. I talked to Bruce Damer only through the week, and he mentioned to me there was originally going to be a games conference and then Artificial Life 12. However, unfortunately, the Games Conference has extended, as these things tend to, and now there's about a 60% overlap between the Artificial Life Conference and the Games Conference. But it does almost lend the possibility for Artificial Life developers to walk into the Games Conference and vice versa. Unfortunately, both of them have a cover charge. In terms of the linking of artificial life into games, I mean, what you're describing with the Tetragotchi may appear to the listeners to still be fundamentally artificial life, but how much of, I understand that you talked to your son about his experience in games and used this to map back into your own thinking with the Tetragotchi. Do you think the movement into being something that's playable online will actually change your own ideas and move your ideas more into gameplay ideas versus what you've done previously in artificial life?
Well, that will be absolutely inevitable because, suddenly instead of toiling away in obscurity on my little program that a couple of people try out every once in a while, I'll be, sort of trying to maintain what probably will be a fairly quickly growing community of people using this game, because it has the potential of, there are a lot of people out there. So, even a few thousand is a big number for me, and it'll be interesting to watch that all grow. But I'll be certainly thinking more of the community growing and the experiences and all the everything that comes out of it, people-wise, more than before. Yeah.
Certainly. So yeah, it does seem to be a re-energizing with regards to your specific direction. And I see Peter Newman in the chat, so he's going to be on the call shortly, and I want to give you the chance to get to bed shortly as well. But you came to New York over just over the holiday period, and you met one of your, I guess, lifelong heroes in the field of tensegrity. Can you give a couple of minutes just to describe that experience?
Sure. The history of it is that I was visiting a sculpture garden in the east of Holland, and I encountered this artwork, which was huge, and it was a tower, a tensegrity tower, and I was just mesmerized by it. So I took some pictures of it and took them home, and I eventually was inspired to start working on this kind of software to imitate that tower in the computer, and eventually I was able to do that, and I was so proud of myself that I actually went and contacted Ken Snelson, who was the artist who had originated this kind of structure. So I contacted him probably somewhere in the late 90s, and we had a short exchange, and so a while ago I realized that I was going to New York for a vacation. I thought, hey, maybe I can talk to Ken, so I connected with him on Facebook and met the man. So this was very exciting for me to meet someone who, several decades ago invented this kind of structure, which I consider to be really still, quite unique and interesting in its potential.
Yes, it was fascinating listening to the interview on the Darwin at Home podcast, because you had a real kinship and a real sense of history, and certainly my own reading with regards to Buckminster Fuller and his legacy and the various ways that he's permeated not only the artificial life community, but a lot of the social and philosophical communities that I have interests in as well, seem to be echoed in an almost kind of divisive point with your conversation with Ken Snelson. And it was interesting to see the other side of that perspective with regards to the kind of overarching genius. But I mean, at the same point, your interest in tensegrity came from Buckminster Fuller initially, didn't it? Or was that independent?
No, it initially came from seeing that sculpture, and only after that did I discover other works of Fuller, which was and Fuller had a different approach as well. It's a long story, of course, between those two guys. But the main thing is that we still haven't really, I think, discovered the potential of what this kind of structure can do. So certainly, and also the linking with biology. I want to evolve them. I still want to evolve them, Tom.
Certainly. And I think, there was some description with regards to linking of biology, and certainly Dick Gordon is also champion of tensegrities within the body, or at least exploring the power of tensegrities within proteins and a wide variety of other things. So it's fascinating to hear that. And look, if there is any chance that you can get here in July this year, it would be really wonderful to have a chance to spend a day or two with you. I'm sure your wife and daughter are, in some regard, a copy of the Gerald Young experience. But if you can get here in any way, shape or form, it would be wonderful to see you here in July, Gerald.
Okay, well, unfortunately I'm going to be on a wonderful canoe trip up in the north of Canada.
Alas. Well, we'll be thinking of you, and certainly if your wife and daughter want to see the greater Las Vegas experience, the Barbalays are the people to meet in Las Vegas. I'll let you get to bed. I see Peter Newman in the chat. I see that he wants to call in currently. It's been wonderful as always, Gerald. We'll need to work out a time where it isn't midnight your time and record another Biota Live in the near future to get an update, because it sounds like things are progressing in weeks rather than months, and I'd like to maybe even get the scoop announcement with regards to release of all of this.
Okay.
Talk to you soon, Gerald. Take care.
Bye-bye.
Hello, Peter.
Hello, everybody.
Yeah, we've got an amazing group in the chat room today. So I think these Saturday shows always get better chat rooms than the Friday night ones. So Eric Burton saying hello. So, Peter, I wanted to invite you on Biota Live, maybe just to do a test for Dick Gordon's Second Life course, but also to talk a little bit about the current developments of the EvoGrid in software terms, the movement to a kind of virtualized EvoGrid, the facility that you're going to be installing the EvoGrid into, and just basically an update in the software of the EvoGrid. I don't even know really where you want to start, so the floor is yours.
Well, as you know, we've been working on a first prototype, which we called Prototype 2009, because that was when we started it. That got to a basically runnable standalone state at the very beginning of this year, of 2010. Let's see. Now, that basically means we have all of the components needed to run it as a standalone grid. We have the simulation, the analysis, and the resubmission loop there. And all of those are using first implementations, first passes of algorithms to do so, but the main thing is that the framework is there, that all of the parts link up, communicate, and they can be upgraded or replaced, but it won't break everything else because we've got the communication protocols more or less in place. I'm sure there will be changes. So we've had that running on just some demonstrations and testing hardware here in my house for a while now. And we're looking at, we've had some offers of some hardware to run it on to develop for testing. We've got, John Graham has tentatively offered us some hardware, assuming that we can get the software to run on the hardware in question. At the moment, we've just recently put up some VMware images because they were the quickest and easiest to put up, because here's the image, it will run. And those can be ran as what I'm currently referring to as a standalone grid, because where they're a closed loop communicating purely in their own terms, because we currently don't have a publicly accessible what we call the simulation manager, which is the central organization point for the grid. At the moment, we don't have hardware to host one of those on, so we set up a version that runs internally that they'll communicate with themselves. That's where we're at the moment.
So when you last appeared, you described the GROMACS simulation and the principles that you'd moved away from the initial GROMACS simulation, and certainly when you did your discussion in Second Life that I think Bruce and Dick Gordon and potentially others attended as well, the discussion was very much about the things that you'd found in the particular tweaks in the implementation that you'd done with the potential to move back. The issues that you were having with regards to dependencies, I understand you actually had to strip out a lot of the dependencies even to get a virtual version of the EvoGrid, even if it was just running locally. Can you describe some of the processes that you had to go through, what you had to remove, and basically the kind of movements away from the core GROMACS source that you've had to do in order to create the EvoGrid as it stands now?
No, we're using GROMACS as is. I haven't touched any of the GROMACS source. I haven't had to remove any dependencies or change anything. The only code I've had to work on was our own, which wraps it. You run our code, it then calls GROMACS after doing some preparation, and then calls it again and again and again and again and again. And that's changed a number of times, but GROMACS in and of itself is a straight installation. We haven't had to. Our initial plan, well, the design is the current design, the current implementation, I should say, is that our code does work, then calls GROMACS. GROMACS runs for a period of time, and then our code does more work again because I did not know how to have that work done in GROMACS. GROMACS does not natively support dynamic bond formation. It doesn't support. When you hand it the initial conditions, you say these are the bonds and this is how they shall stay. However, later during that development, I found out that one of the things that they were referring to, that they referred to as, they just referred to it as QM, and I didn't know what QM meant. And then after I'd been developing code to do the dynamic bonding in our code between runs of GROMACS, I thought about the terms and so forth, and then came back to the QM concept and realised that was in fact their own code to do what effectively I was attempting to do. And at that point I went, all right, well, we need to get all these things communicating and working together, all those parts in that closed in the loop that I mentioned. So I went, rather than scrapping what I've done and starting again, I'll continue with what I've done with the intention to get data moving between all the parts sooner rather than later. So now that we have all the parts connected, one of the things we're looking at, and certainly at some point on the list, is to move to using GROMACS code for quantum mechanics, QM, quantum mechanics, to do the bond formation, to do the electron and proton interaction, I assume is what it seems to be about, to rather than bonds being first order, but these atoms are bonded, it calculates the interactions between the electrons and protons, and from that bonds will emerge, as I understand it.
So, I mean, for folks listening in who are scratching their heads about the details associated with this, the details relate to, in what you'd see, I'm assuming, the physical proximity of the molecules and how the underlying quantum mechanics interactions create tighter bonds in some regard than you would model through more classical molecular dynamics modeling. So the quantum mechanics will actually create tight bonds, but also suck the molecules in more. Basically, is that the way you're seeing it as well, Peter?
Well, at the moment, at the classical molecular level, where bonds are specified as first order, you have your weak forces and your strong forces. You have your covalent bonds, which you specify, and then you have the attraction repulsion between atoms that are not in any other bond, which they refer to as Leonard-Jones. It's when they're far apart they attract, but as they get closer they start repelling each other, so they end up in some sort of balance there. But you also, those are your weak force, what they refer to as the weak forces. The strong forces are the exchange of electrons, where two atoms are sharing an electron or an electron pair, and those are what they call as the strong forces. In traditional molecular dynamics, those are specified. Those are specified using a bond type, how you want that bond to be simulated. And in the quantum mechanics model, they will simulate the electron exchange rather than saying these two atoms are sharing an electron or two pair of electrons, and that's it. They'll simulate that exchange happening, and the bond will act. the exchange will cause the atoms to interact as though. I'm sorry, it's got an error. That will cause the atoms to interact as if they're in the same way that they would have if you had specified a bond. But in this case, they'll also be able to break said bond and move apart and so forth.
Certainly. And you're also leveraging on the fact that whilst people can run GROMACS without the quantum mechanics components, the quantum mechanics components of GROMACS, or however it's added into GROMACS, is also tested by a wide variety of teams. So you've got tested relatively stable code in that component as well.
Indeed. It's GROMACS is a long-term project. I mean, they're up to version 4, but I believe it's been going on for at least between 20 to 30 years. There are references to the 87 format, which I believe to be 1987. And the code, the quantum mechanics code, is an option. It's in the code base that exists. It's not an add-on as that would have to add on to people's systems. If they have GROMACS, they most likely have the quantum mechanics there unless they changed an option at compile time. But the code is there. So in those terms, it's it would be like you said, it would be well tested and seen by a lot more people than just the users of the EvoGrid program.
So the EvoGrid as it currently stands is really a wrapper around GROMACS, which enables the discussions associated with almost possible universes or spawning or these kind of interactions to be added into GROMACS, and then the output to be tracked in terms of whether that is passed on, whether it's considered sticky and interesting in terms of farming it out into more population, or whether it's in fact discarded. In terms of what Bruce is talking about with the EvoGrid currently, I've listened to some of his more recent talks, and the underlying philosophical stickiness in some parts of his talks are left behind. But in terms of your communication with Bruce, can you see anything that would dramatically change in the creation of the EvoGrid in software that would require Bruce to change his communication of the EvoGrid in terms of summoning the EvoGrid? Do you see them as two almost separate projects? Or, can you describe the interaction for the listeners?
Most of Bruce's presentations are 2 or 3 levels of development ahead of where I'm working. I look at the code. I have my head at this level where I'm working now. And when I listen to Bruce talk, he's talking future stuff. I haven't, so in terms of the changes, there's a number of, I suppose you would say generations. I don't mean as in like discarding the code or releases. I mean the points of development, milestones. There's a number of generational milestones between what we have now and what Bruce often talks about, and I think that pretty much anything could happen between now and then.
Yeah, it's very interesting because certainly I take great interest both in what you're doing and what Bruce is doing, and tracking these things almost like they're two separate projects. You have Bruce going out doing the talk, summoning the EvoGrid, and then you have your development, which, as you say, is, I wouldn't necessarily characterize it even as 3 steps behind, because I think some of the insights that you make change the way Bruce describes the summoning fundamentally. So I think there is probably a closer interaction. But what interests me is the potential for you to, for example, now you have it in a virtual sense, farm it out to receptive folk, even though in that regard they're still all localized EvoGrids. But the results that they produce come back to you, and then it's almost like you're at the point now where the implementation of the interesting stuff, i.e. you've moved past the kind of initial bug fix point. You're now moving to the point where you're going back to the quantum mechanics, which was, from my perspective, a bug fix in some regard. And you're now getting to the point where you're actually getting data back. You've done your first initial run of data, and now you're actually farming out the simulation to gather data elsewhere. So from this interaction, the process that Bruce describes with regards to the EvoGrid is about how you actually analyze this data in a way where you can start making decisions about which data is important. And currently, you're doing this, aren't you?
That's pretty much what we're at, yes. I personally look at it in terms of correctness, and I don't look at it as a chemist, which is something we need to get. We need to get chemists and physicists and so forth on board, which is part of our next thing. But yes, that's where we are. That's why I've got the virtual images up, is to get basically more eyes on the problem, to give something people they can look at and actually think about and talk about, and then hand back information about.
So, as you're talking currently to at least 400 interested people, if not potentially thousands, because these podcasts have tails that are almost infinitely long thanks to the Internet Archive. There'll be people listening to this in 4 years' time afresh. I know people now who have been listening to the Biota podcasts and are 2 years behind because they're still catching up. So the potential for people in the future to listen, and maybe this is less of an offer, but for the 400 or so folk that are currently listening and are obsessive and are part of the community that is Biota, what would you say to them? And can they contact you and get the VMware version and run it currently? I mean, it's not just because the person you're communicating with has a large lab of computers that he can put this on. It's potentially getting to the stage where anyone in the community could get the virtual version, run it locally, and then give you back the information.
Yes, it's I'm not sure if it would work with the free standalone VMware player, but anyone who has a VMware workstation or any of the slightly higher quality products that VMware puts out would be able to run it. As I described it in the email to the email list, I said, so we have the alpha release here, we have some VMs. Don't sound the, these are the first pass. These don't sound the trumpets, but do tell your friends. There's still a lot of development to be done, but they are something. They will sit there and they will produce results. We're still working out whether the results are actually useful or not. They can be gotten, at the moment they're on the SourceForge site for EvoGrid. They're in the file section up on SourceForge, so they're quite easily available in terms of that. I haven't actually put a news release onto the EvoGrid site yet, as this is a fairly new thing. And I just was waiting for feedback from one user, one tester, to make sure that it wasn't just me that they worked for, before putting up I have a news release prepared. I just haven't linked it into the main site yet. But people can either get it, people listening in the future will be able to go to the evogrid.org site to get them. People listening to currently can go to the SourceForge, the EvoGrid page on SourceForge, and get them from there.
So that's sourceforge.net/project/EvoGrid.
That's right. I believe also evogrid.sourceforge.net that will go to the evogrid.org site, sorry. So you were right, your URL was the correct one.
Yeah. And in terms of this idea of the community, I mean, this is something that I've been talking about with Bruce since before the EvoGrid was the EvoGrid. I remember walking through the summer, 2 summers ago in Las Vegas, actually walking along a railway track, which I memorialized by a YouTube clip the next day. So I could show Bruce actually the rustic nature of the area that I was talking to him in. But the idea of creating the community around the EvoGrid, this is really a metaphor also for the idea of farming out the processing to a wide variety of processes. This is also the nature of the summoning the EvoGrid idea, that you're also farming out the process to a wide variety of minds as well. And I think this is the really interesting part of the project, because this is the point where you have something to display. It's not just Bruce going around talking about it. And you're looking for community feedback You've mentioned that you need to get biologists, potentially biochemists, potentially chemists involved at this stage. Obviously, there's a good degree of software, and also, as Bruce has found, it's incredibly philosophically sticky in terms of folks who may not have background in any of these areas but may feel particularly passionately about the project as a whole. In general terms, project in 3 months' time, what would your dream be in terms of people that would be involved with the EvoGrid as you work on it?
Well, the main thing that we need in the immediate term is we don't words. I mean, while I say chemists and physicists and so forth, the main thing that we need at the moment is algorithms. We don't even need code as such, as long as we have algorithms for the analysis. For example, at the moment, our analysis that we do, the complexity testing that we do at the moment is it's very primitive. It's very quick and simple tests that relate vaguely to just an off-the-cuff definition of complexity that was easy for me to implement because there happened to be a library function that did this particular piece of maths for us. And I went, okay, that will do for a test, and we'll prove if it works, if the loop loops, if the feedback loop works.
For a point of clarification here, Peter, when you say complexity, you're not referring to complex numbers, you're referring to large multi-body systems.
Yes, the complexity is sort of one of those buzzwords that's been used in the description of the project without being clearly defined at any real point. My personal my use of it at the moment is larger molecules and rather than larger, more common molecules rather than just simple things like oxygen and rather than say two atom molecules, I'm looking for multi-atom molecules at the moment. And a larger definition of the term is one of the things we need with these algorithms and precise ways of saying that this is what we're searching for at the moment. We have just, like I said, an off-the-cuff definition of the term, so to speak, and an off-the-cuff algorithm for finding it. And that's what we need.
My own sense of what you're describing is something that comes from the mid to late 80s and early 90s with regards to chaos mathematics, because what you're looking for is almost like fractal complexity, aren't you?
There's certainly certainly one way, There's certainly one thing that could be used in the search, yes. I don't know whether it's the be-all or end-all because I don't know enough about it.
So the background with regards to fractal complexity is that it's not just creating Mandelbrot sets. It's a numerical representation of shapes and forms in such a way that you can say something is particularly complicated as a shape and form, but the underlying structure itself, it's almost like a delta, is complicated too. And I think it's interesting in our community, the people that have this knowledge are folks such as Rudy Rucker. I'm trying to think, there was a mathematics friend of Bruce's who was a chaos expert as well. They're not people who would traditionally be part of the artificial life community. They're people who are really on the fringes or in other communities that are artificial life sympathetic. So in this view, when you create your press releases, you're calling it, obviously the aim is to get this press release circulated on a wide variety of mailing lists, not just the artificial life community mailing lists. But it would be very interesting, and Bruce has the right contacts in the Bay Area in terms of the chaos folk, the kind of late 80s, early 90s mathematicians who drove a lot of this, to put the word out through those mailing lists as well, because I think they're exactly the right people for what you could be dealing with here is something which is quite a bit different to kind of chaos complexity as well. But in terms of the interesting minds, I think that's certainly a group that could give algorithmic feedback fundamentally on those kind of problems.
Yes, it's definitely a something that will go across different groups, I think, because it doesn't even exactly apply to the A-Life group. I mean, here I am talking on an A-Life podcast, but it's not even, at this point, it's not even really about A-Life as such. It's because A-Life is, I mean, in my mind, and I'm sure there's a number of working definitions, is about abstracting the process of life to fundamentals and finding out what are the fundamentals, whereas this, we're coming at it from the other end, which is something I haven't seen very much. But yes, Bruce is certainly the public contact, the public face, the guy who goes out and shakes hands and rubs shoulders and meets people. I'll just stay here and work on the code. Thank you very much.
It's certainly something that Bruce and I have discussed frequently. I mean, I think the part of Australia that you're in, and I mean, look, I'm being completely foolish here because the community at RMIT and Monash in Australia has a number of academics that are exactly the right people to talk to with regards to chaos complexity. So, I mean, I think the stuff that I've talked to with Bruce is finding the kind of intellectual support group in your particular area that could lend their own insights. I mean, even John McCormack is someone who could give real insight. But I think what interests me as well is within these schools there are probably groups of students, and I'm thinking of the recent ACAL conference. I got feedback from Jeffrey Rentrella and also people I knew in Australia who attended, and there was really quite a tight group of students and graduates that have come through Monash and the surrounding universities that I think would be very interested in the EvoGrid. And in terms of creating a local support group where you could have face-to-face access to the kind of people that could give you, if not direct feedback, at least references. There's certainly a wide variety of folk in your area. But I also, and this is something I've said to Bruce on multiple occasions, most recently only a couple of nights ago, think that you need to come to the US as well to get a sense of the community here. I think the nature of remote work, and I do this all the time, I mean, you may have heard the end of my call with Gerald where I was saying, you know, Gerald, if there's any way you can come to Las Vegas, the nature of actually meeting people on location and getting a sense of what they're doing and having a real sense of the community as people, which I don't personally have either, aside from meeting Bruce and Dick Gordon, that I think would also give you benefit and also reinforce that the interest and the excitement about the EvoGrid was very real and came from actual people. So certainly that's something I've reinforced with Bruce, that I think the community around you exists, real people in relative physical proximity to you that could give fascinating feedback into the EvoGrid and be real inspirations with regards to the stuff that you're doing currently. And similarly, the whole community, you know, if we have Biota 5, for example, in a year's time, I will say to Bruce in no uncertain terms that it'd be critical for you to be at Biota 5. And I think these kind of community gathering points require folks such as yourself and folks such as myself and everyone else in the community to kind of work to actually get there. Because I remember talking to Jeffrey and Gerald, they both echo this story actually, about the Biota conferences early on, that it was in fact the interactions that weren't formalized that produced the most interesting output. And certainly I don't think what you're doing with the EvoGrid is, I don't want to say necessarily unique, but certainly there are a number of shared experiences of community that is around you physically that could probably assist you and give you a great degree of benefit, particularly with just little incidental problems. I remember your discussion in Second Life about the interaction with regards to bugs and these kind of things. There's a lot of old, I don't want to necessarily say conventional wisdom, but at least, you know,
definitely.
There's a community that has had these kind of experiences with regards to their own specific projects, and the ability to interact with that community should not be ignored. And I also think it takes Bruce, in terms of his interaction with the EvoGrid, has been very good at the summoning component, but there's still a kind of documenting component, there's a formalizing component, and there's what you're doing as well that I think would benefit from Bruce's input and a number of other people in the community. So this is the call out to the community, basically, to help Peter out with his current stuff as well.
Yes, come, help. Help!
So, I mean, with regards to, Bruce is going to Artificial Life 12, which I think is in July this year. There will be a few other folk from the community attending. You, Bruce, Dick Gordon and I will be writing for Artificial Life 12, although Bruce will be the only one of the four of us in attendance. In terms of the speaking things that Bruce does and these kind of things, I think if you created a community in Australia, it would almost force Bruce's hand coming out and talking to the community. But what Bruce is looking to do, and this starts in Second Life, but I think we'll move into real life, is get you to talk more about your own experiences with the EvoGrid. You obviously see this transition happening.
I'm not sure I follow, actually.
Well, I get the sense that basically what Bruce is doing, and this is a narrative from the start of the call, is that there is a summoning, which is what Bruce is doing, and then there's a developing, which is the thing that you're doing, as you described, currently in isolation, but a development that you will lead in parallel to Bruce's ongoing summoning efforts.
Yeah. Bruce thinks up ideas, and then sometimes I get around to making them.
But in terms of the structure and organisation, I'm not sure if you heard the part of the call with Gerald, but Gerald's just about to launch a particular version of his DarwinAtHome development, which creates almost like a massively multiplayer game component. And
I didn't hear that, but I have been following his blog and following
the podcast, and yeah. So the interesting thing about that is the potential for these things to explode in a relatively short time frame. I mean, you spend what appears to be years doing stuff in isolation, and then all it takes is you're basically laying gasoline around yourself, and then all it takes is a single match to get it all to explode. So in terms of the progress and the infrastructure, I think certainly my discussions with Bruce have been, particularly recently, in the vein of this thing could explode very rapidly, and you'll have a situation where where the source code could overtake the summoning. I mean, that's really the nature of my questions around that as well. But I find, personally, as a kind of artificial life practitioner, I find a lot of what Bruce talks about conservative in terms of the artificial life community. I think there is a potential in the community as itself to create things which we aren't even capable as kind of muses of talking about currently. There are different directions, and even thinking about when I started Biota Live, where we are currently is in a completely different direction than the way that I started. But a lot of that has come through development. It's not just a talking movement. It's not a philosophical movement. It's something that's backed up by software. It's backed up by things that happen very much in the kind of technology domain in parallel to the philosophical domain. So in those terms, project yourself in a year's time in terms of the development and infrastructure. Suppose that you gather together within the next 3 months an intellectual group that is able to help you on location, coders, these kind of things. Bruce moves through the PhD process and is probably coming to the end of the PhD, and someone hands him a check and says, the EvoGrid is go. What's your own thinking in terms of the mapping of the process, or are you really still caught in the kind of, day-to-day bug fixes and details? What direction would you like to see the EvoGrid go?
I mean, I'm certainly still with my head at the level of just, getting it working, and I've been focusing, yes, definitely on the day-to-day. Taking a step back and looking at the larger picture, it's interesting because, as I said, I've been so focused on the day-to-day. I don't know where it will go. I mean, once I have something, which was my aim and which I have now, and at the moment once I finish polishing these rough corners off it, these very sharp edges that are on there still, I definitely think it could get picked up and ran with, and that's sort of my hope. It's like, get it there and then give it to people and then say, now what do you want to see done with it? Or what do you want to do with it? What do you want to see done with it? and what do you want to see other people do with it. And I think once I have, while these sharp edges are being worked off, I think the next important thing will be the community and the public interest and the mind share, I suppose, would be also a good term. Where it will go from that, I'm not entirely sure. I know that there's a number of different directions it's being presented in. It's being presented as a chemical analysis for wet chemists, people who do actual chemistry. It's being presented to the ALI community, obviously, as we speak here. And every now and again, far-flung ideas come up, like asteroid eaters. That was one that sort of came out of nowhere that was a little surprising.
But there's the potential also for Gromax to be thrown away, isn't there? I mean, there's the potential for, and the way you've designed it currently is very much where the central part of it can actually be completely updated, disposed of. If there is a better package that comes through, the interfaces are still not dependent on Gromax being the centre in the future, right?
Well, that's the idea, certainly. We've had someone mention that there was another simulator, I think it was LAMS, that we should look at, and that it could do things that we would find useful. But the idea being is that all of these parts communicate over a documented open standard. They don't just hand Gromax data to the other part. It's converted to a format that we've got that's vaguely documented and human readable. It needs more documentation, and that's the next thing I need to work on. Always with the documentation. But the idea is that, yes, any part of this process could be completely replaced, and as long as it kept to the same externally speaking standards, they all speak over a web protocol at the moment, HTTP, and they pass web machine readable data over HTTP. And as long as any one of these parts is able to provide and read those pieces of information, there's no reason for any of our software or parts of our software to stay there. That it could be a complete replacement, and that would be great, because we're like, hey, our design works. It was designed to be able to do this, and it can. This is great.
Certainly, and I think that's the interesting part of the community. The community input too. That certainly in the discussions with Dick and Bruce and others, in terms of possibilities versus actual. Even modelling methods currently, which is even one more step removed from reality, if such a thing exists in these kind of simulation spaces. The potential for EvoGrids with different physics, with new physics, with simplified physics, with more complicated physics, all these kind of things still are possible with the current development practice, and it sounds like that's going to continue on into the future. So I agree with you. I think it could go in a wide variety of different directions. But certainly the progress, if I think about probably 2 years' worth of discussion with Bruce and the amazing progress that has occurred really only in the past probably 6 months to a year, I mean, a large part of that is your development, Peter.
Yeah, I mean, ideas are good. People have got to talk about these things. Talking is good. My personal view is that talking doesn't get, while it's good and gets the ideas, at some point something has to be done. That you can come up with a brilliant design, but someone has to actually write it. And then once you've actually got something, not something you can pick up. It's the same to having something you can pick up and touch, although in this case, obviously, you can't. You can just run it. But when you have something you can pick up and touch, and suddenly all those ideas that you had, you look at it and you go, yes, this is what I mean. But, oh, wait, let's go in a new ideas will occur to you that you never would have thought of until you had that object in your hands, or in this case, running on your computer.
Well, Peter, it sounds like you've got a busy Sunday morning happening in the background, so I don't want to take too much of your time, but it's been wonderful to have the chance to chat with you today, and please come on a future Biota Live, probably at a similar time or maybe even slightly later, to discuss these developments as they continue.
Oh, I will. I intend to. Now that I've got the time zone conversion worked out, for some reason... Oh, no, your other show that's on the Fridays, that was what threw me. That's right.
Yes. No, I'm going to probably be moving around times because Gerald mentioned that it is phenomenally... I either get phenomenally early for him or phenomenally late, and this is phenomenally late for him. But similarly, I also want a time which is ideally suited for you too. So thank you once again for the chance to chat with you, and I think you've given the applied EvoGrid versus the summoning the EvoGrid update for for the next month at least. In terms of the timeframes that you're discussing with Bruce currently, there's a lot of writing that's going on in the next few months, but you're developing in parallel as well.
Yes, there's a lot of writing. I need to actually sort of get off the development and do more writing myself. It's a little hard because it's like, oh, I could do this. Ideas keep occurring to you. So it's like, oh, I'll just write this, and then, it's a week later. I definitely need to get onto the writing myself as well, but and while we collect feedback and initial responses and so forth from this first release that we've got.
Well, thank you very much for appearing on Biota Live, Peter, and I look forward to talking to you in the future. Take care.
Thank you, and I'll see you in the future. Okay. Goodbye.
See you. And for folks listening in, this has been a first of the Saturday afternoon recording Biota Lives. We're going to be changing the time format, although it'll be recorded on a Saturday in the future. 2 weeks' time, in fact, probably around the same time, depending on the topic that we pick. If you have a topic that you'd like to suggest for a future Biota Live, please contact me directly, tom@noble8.com. The last Biota Live received probably the most correspondence that we've ever had from new listeners, old listeners. A lot of correspondence from the last Biota Live, and I was talking with Bruce Damer about it through the week. And I think there's probably some benefit to almost structure the Biota Live so we have a wide mix of topics, because certainly what came through is that there are a group of listeners that really like topics as they were discussed last week. There are a group of listeners that would like us to stay on topic, which perhaps we diverted from with the Biota Live that occurred last time. And there are also listeners that would like to see new topics. And if you're one of those listeners, don't be an anonymous listener, please. Step forward. Email me, tom@noble8.com, or alternatively, join the Biota Conversations mailing list and see the follow-on discussions from tonight's Biota Live. And in the future, I think we're probably going to have a little bit more philosophy in the podcasts. I know the last Biota Live maybe necessarily wasn't that philosophically heavy. It was on particular points. But I think certainly the interaction of Liz Swan, and like I said with regards to the Biota 5 conference, that's been pretty well single-handedly organised by Liz Swan with some assistance from Dick Gordon and myself. So there may be more philosophy coming in the podcast in the near future. If you don't want to see that, if you'd like more technology, if you'd like more discussions that occurred on this podcast or this particular Biota Live, please get in contact with me as well, tom@noble8.com. This is purely listener-generated. Biota Live exists purely to communicate the interests of the community, and as you're listening to this, you are part of that community. So please get in contact. Let me know what kind of Biota Lives you want in the future, and I look forward to recording them for you. Herve Noel, who has been a long-time listener, and the reason that we do the Biota Live light versions of the podcast, will be appearing on a future Biota Live as well. So I'm yet to work out the actual details with Herve about which particular date would work best for him. He's currently in Mexico, which puts him in a relatively good time zone to talk to me on one of these Saturday afternoon Biota Lives. So I'll certainly announce that through the mailing list when he's on. I know Eric Burton in the chat has been very interested in getting Herve on a Biota Live. Maybe so Eric can call in and participate too. Anyway, thank you very much for listening in. I'll talk to you soon.